Welcome back to Introduction to Agroecology, Unit 6. This is Part 2, and we're going to look at the environmental factors again. This time we're going to look at the effects of temperature on the variation within the environment. For the effect of temperature for a plant and for animal growth and development, it can affect both. The limits of the tolerance for high and low temperatures. In other words, their plants will only grow and animals will only live within certain temperature ranges, and so they have their optimum range. And it can also vary based on the development stage of the plant. In other words, in animals too. Generally the younger it is, the more unable it is to go outside of certain ranges, and the older it gets, the more it will be able to, and then it reaches a point too that once it gets old enough, it's going to be affected, kind of just like humans. It's going to limit which crops can grow in an area. In other words, if the temperature doesn't get to the right range for that plant to grow, you certainly can't try to grow it there. A good example is pineapples, coconuts. They really wouldn't grow in the Midwest. You don't have a long enough season in order to grow them. Another important factor is the temperature of the soil. It would be an important factor because if it doesn't get warm enough, it's not going to allow for all of those processes to happen. Some of the stuff which kind of is we talked about in part 1 of this section, the ecological factors, or in other words, of the ecology of the area, the latitude, altitude, the seasonality, whether or not you're in a maritime or continental influence. Maritime would be on east or west coast by the oceans. Continental is the area in between. And then the type of topography that you have, in other words, if you're flatland or mountainous, hilly areas, would also affect how the plant's going to grow. The latitudinal variation, the amount of solar radiation that is absorbed is greatly affected by the latitude. So in other words, because of that intensity of the light that's coming in, that when it's more intense, there's more of an ability to have the right angles so that the soil will warm up more. And then, if you're at the equator, it's going to meet that surface at a vertical angle. As you get away from the equator, the angle is going to be more shallow. So in other words, the closer to your equator, you're going to have a more intense exposure, and that's why it's hotter and stuff, grows way differently close to the equator as opposed to the farther away you get. That radiation from that light is spread out over a larger area too as you get away from the equator based on that distance of that latitude that you are away from that equator, away from the equator. Here's just a graph that shows the temperature changes as you get away from the equator, and you can see there's a large amount based on where that is, on which latitude you are, on the range of what that's going to be. Altitudinal variation. As the latitude increases, the result in decreases in temperature are going to happen no matter the latitude that you're at. That sounds confusing, but what it's saying is for every 100 meters of elevation gained, in other words, the higher you go up, the altitude, the higher you go up, the temperature on average will result in a 0.5 degree centigrade increase. But the air is thinner at the higher altitude, so it results in a loss of heat because it's going to bounce off and go up and be away from you because of the thinner soil and at a quicker, in a quicker fashion. For seasonal changes, it's caused by changes in the orientation of the Earth in relation to the sun on its axis. In other words, I said the sun is going to be farther to the east or farther to the west. It's not going to be straight above, and it's really the Earth that's moving, not the sun. But based on that, you're going to get longer or shorter days And when you get into the summer, you're having the longer days, so you're going to have more solar gain. In other words, the plants are going to be able to take that, do the photosynthesis with the creation of the carbohydrates and sugars in order for the plants to grow and produce the crops that you want. It also, the variation is going to increase the farther you get away from the equator. And when you're at the equator, it's going to be pretty constant the whole time of year. You aren't going to get a variation, so that's why you can create the multiple crops. Maritime versus continental. The coastal temperatures are greatly affected by large bodies of water. The water temperature takes longer to change than the land mass. In other words, the soil is going to get warmer quicker than the water does. And it's also for the maritime areas, it's going to be more of a moderator of the temperature. You aren't going to get as high. A good example in the Midwest, in Chicago, if you're by the lake, if you pay attention to the weather, the lake affects in the summertime that as you go farther and farther away from the lake, it's warmer and warmer and warmer, and it's cooler by the lake. It's that lake that's causing the winds coming off the lake that are cooling the area right around the lake. Whereas if you have a continental influence, you're going to have more or a greater temperature fluctuation than you are in the maritime regions. In other words, in the summer it's going to get warmer, in the winter it's going to get colder, away from those larger bodies of water. And even though we'd say we have a continental influence in the Midwest, it is certainly affected by Lake Michigan, or any of the Great Lakes, or any large bodies of water are going to affect the area right around them. But the maritime influence is more talking about at oceans or the gulfs that are out there in the world. Topographical variation. And that's basically saying that your slope, we talked about this a little bit in the last section, but basically if you have a slope that's east or west, you're going to receive that sunlight more in either the morning or the afternoon, but you're not going to get as much if the hill or mountain is high enough. If you're facing the equator, in other words, it's a north-south orientation because the sun goes east to west, you're going to have less of a change. It's going to, in other words, be more intense because that slope isn't going to be affected as much because of the way it's facing. Valleys near mountains also create special microclimates. One of the best examples is Napa Valley, Sonoma Valley, but there's areas in Wisconsin that have great areas for bogs that in the hillier areas, but Napa Valley, based on how the temperatures are and the changes and the moisture that's held there at different times of the year and different times of the day, you get the grapes that are at Napa Valley or Sonoma Valley, and that's why they're so good there compared to other areas. Local conditions on temperature, humidity, and the atmosphere in the immediate area of the plants is called a microclimate. In other words, micro is smaller, so it's not the climate of a whole huge area, but it's just one little ecosystem, the area that you're in. So are those conditions that they're talking about. Temperature generally will be considered probably one of the more important factors of that, although humidity might make a difference. And of course, if you're up higher, it's going to make a difference for the atmosphere for how intense the sunlight's going to be. And the more intense it is, the higher temperature you could have in that microclimate. Things that can change a microclimate or do change a microclimate is canopy vegetation, in other words, that tree cover. There could be non-living canopies. You could have buildings that make a difference in terms of how stuff grows because it's covering up part of the sun part of the day. If your plants are close enough to it, it could be hedgerows that make a difference for that. The covering of the soil surface too, depending on if there's no cover at all, in other words, there's no crop on the ground, or if there's a lot of blacktop or roofs of houses, you are going to get more reflection of that light, so it's going to get hotter in an area because that soil surface is not able to absorb that, or those plants aren't able to absorb it. Some of the things for how we modify climates, we can have either greenhouses, hoop houses, or shade houses. Greenhouses are the glass or plastic covers. Hoop houses generally have a covering over them, some to totally eliminate the light that's coming in, or at least filter the light that's coming in. And then the shade houses are ones where basically they're screens where you don't get a whole lot of sun, but you get a little bit. And that can certainly affect the climate of how the plants are growing. And here's just an example of, and you see the difference of what it looks like in the forested areas and right around that, and in areas that don't have that vegetation and how much difference it looks. There are ways within an area within a microclimate that you can try to do things like prevent frost from occurring. You can mulch or cover the crops, although if you have a big area that might be hard to cover them. Misting plants prior to a frost. Down in the warmer areas that don't get frost that often, but they sometimes do, the orange groves of California and Florida, they will mist the plant, and that puts a little bit of water on the plant, and it will actually be a protective coating if it frosts overnight, believe it or not, and then it melts off when the sun comes up the next day. Another way they do it is they have heaters, kerosene heaters that they'll put out into low-lying fields. They call this process smudging because it's a smudge pot. And that basically can help keep an area warm, but it does a limited thing because if you still have the cold above it, you have warm and cold mixing together, but warm air rises, so that's how that works. And then you could have an increase, you can try to increase air movement. A lot of areas will use large fans and try to move it around to keep it moving so it doesn't freeze and it's a little bit warmer in the area. You can do the non-living canopies, the covering of the soil surfaces, again, talking about the greenhouses, hoop houses, how you can try to prevent frost from occurring. So some of the same things in different ones, you can modify the climate based on that. In some areas, you use hoop houses even in the wintertime. You can extend the season of growth. Even though you don't have the sun, there's certain crops that will grow in earlier or later in the season as long as there's protection from the frost. Challenges that still exist for trying to find better environments that aren't as expensive. So in other words, if you're protecting against the frost and spraying water on it, that takes manpower, it takes water, which is becoming less and less available and more expensive. Building hoop houses could be expensive, so we're trying to see if we can do things. They're trying to do research to see if they can change these environments to make stuff more cost effective. And then also trying to rely on renewable energy outputs, external energy outputs, in order to be able to, in other words, taking solar power and harnessing it and then maybe using that as opposed to using kerosene to use those heaters. So there's that kind of research that's going on to see if we can make it better in terms of what we're using for energy. And then this is the attribution page for the pictures. Go back to